Lesson 7.1, solving linear systems by graphing. Linear system means there's two equations and both of them are linear. This is a linear equation over here, and this is a linear equation over here. So let's graph them and see what happens. So down 3, up 2 over 1. And when I solve these by graphing, I'll often make a lot more dots than I have to until I figure out what's going on. So this goes up 2. I'm going to put this in a different color. And it's down 3 over 1. So they intersect right there. Just kind of the point of what we're doing, to see where they intersect. Looks like they hit at the point 1, -1. And we can check. Let's see if it works. If I put in 1 here, -1 here, 1 here, -1 here. Are they equal? 2 times 1 minus 3 is -1. That one works. -3 times 1 plus 2 is -1. That one works. So we just figured it out. They intersect at 1, -1. And we just answered this question too. How do we know for sure they intersect? We checked. So, try another one. X plus 2y equals 7 and 3x minus 2y equals 5. What do we have to do first? Well, we've got to move them into something that is easier to graph. Could graph it with intercepts. Not a terrible idea. I always find this is just a little bit easier for me. So -1/2 x plus 7/2. 7/2 is 3.5. 1, 2, 3.5. -1/2 is down 1 over 2. Down 1 over 2. Down 1 over 2. Let's see where this other one ends up. See whether or not I need to add some more points. -5/2 is -2.5. 1, 2. And 3/2. 1, 2, 3. 1, 2. 1, 2, 3. 1, 2. Looks like they intersect right about there. And I said looks like. We don't know for sure. So this point is 3 over 2 up. Let's check them, see if they work. 3, 2. 3, 2. 2 times 2 is 4 plus 3 is 7. Works. 9. 3 times 3 is 9. Minus 4 is 5. Works. So we checked our solution. So that's all we're doing. We put the 2 points on the graph, 2 lines on the graph, and see where they intersect. If they work, we check, make sure. We can do this algebraically too, and that's what we'll be doing in lessons in the future. However, there are 2 possible exceptions. Let's see if we can find one of them. First one's already set up. I don't need to do anything with it. Down 5, down 1 over 1, or up 1, left 1. The other one we have to manipulate. So it's -x minus 4. And graphing these lines, we realize they're parallel. How do we know that? Well, they have the same slope. So I don't even need to graph them. If I notice at the same slope here, and that they had a different intercept. Oh, that's +5, so this should all be up. Let's fix that. Got ahead of myself. We have no solutions. They're never going to intersect. There's no points that'll ever work for both of these. We could also write this, which means null. Means an empty set. There's no solutions. So if you want to look at it algebraically, you just say same slope, different intercept. They're not going to intersect. So that's one of the two exceptions. Let's look at the other one. This one's already set up, -x minus 4. Manipulate the other one. Y equals -x minus 4, which is the same equation. So when I go to graph it, it's going to land right on top. So we've got same slope, same intercept. We will have an infinite number of solutions. Not any solution, but an infinite number. So any number that fits one of them will fit the other. For example, one possible solution would be 0, -4. And you'll notice that works in both of these. Another possible solution would be -4, 0. That works in both of them. So there's an infinite number of pairs that you can come up with, but they're not just any random number. So these are the three possibilities we'll have when we have two linear equations. We have an intersection. That means we have different slopes. And they will intersect eventually, even if not necessarily on our graph. We have no solution. Means parallel lines. And a parallel line is by definition not the same line. And we have an infinite number of solutions. And that means it's the same line. You may not recognize it right away, but it's the same line. When you go to graph it, they'll land right on top of each other. Lots to absorb here, so get going practicing on the problems. Good luck.